All right, folks, here's some calculator keystrokes for your regression procedures. Uh, we're going to use the NEA fat gain example from the second video. Stat edit. First thing you're going to want to do is get the data into your calculators. Remember the NEA change is our X and fat gain is the Y. And by the end of it, you should have 16 entries in each list. So if you need a second to pause, go ahead and do that to get the data in. Once the data is in your calculator, we want to do a couple things. We want to assess the linearity. We want to check the residuals, the residual plot, and the residuals for normality. Those are all the things we want to do. Just as a quick refresher, if you just want to make a scatter plot of the data, you go in second y equals, turn the plot on, and tell your calculator you want to graph L1 versus L2. And let me just make sure my other plots are off. And zoom 9. Let's try that again. Second stat plot, plot 1, there we go. I think I change that to L1. There we go. Let's try zoom 9. So there's the data. We already had it, but just if you needed a refresher on how to graph the scatter plot. That's going to be our same procedure for graphing the residual plot, but we need to get the residuals first. So we'll do that. That would be the first thing to do, is take a look at the residual plot to assess the linearity if the scatter plot is not really good enough to do. So you may or may not recall that in order to get the residuals in your calculator, well, you could do this by hand and take each of the y's, subtract the corresponding y hat to get the residual. But that's too much work. No one's doing that, I hope. So in order to get the residuals in your calculator, you are going to run the regression, and you can choose 4 or 8. Because we're using a plus bx as our equation for these regression procedures, where b is the slope, I would probably just use 8, so there's no confusion about anything. L1 is your x, L2 is the y. If you wanted to store the regression equation, you could. That would come under the vars tab here, vars, y vars, enter, enter. You do not need to do that, but you could. The whole point of running the regression, though, is you get all these values that you had in the table anyway. You knew these. But what it did is it calculates all the residuals and stores them. And what we want is to graph a residual plot, which is the residuals on the x-axis. We want to graph the x's against the residuals. So we're going to put the residuals on the y-axis. So in order to do that, we need to do one of two things. You can do it straight from the plot page. So I'm going to actually turn this guy off and go back to the plot page. And I'll turn on this other one. And I'm going to graph L1, which was my x's, against the residuals. Now, the question is, how does I get that in there? Well, just like the contributions in the chi-square, these come out of the list. So second stat, and you'll have to scroll down. Mine ends up being in the 9 entry. Yours may be somewhere else. But you could just shove the residuals in there, and you're going to graph the x's, which were in L1, against the residuals. And if we zoom 9, that's the residual plot. That line that you see up there is the equation, the y hat line that I stored in there, but kind of forgot about. But the question is, do these points bounce around 0, or is there some sort of pattern that exists as x goes from left to right? And I would say overall, no, there's no clear parabolic pattern or anything like that. This point maybe concerns me a little bit if you're thinking about heteroscedasticity, some fanning as you move along x, but not enough to, remember to when you're evaluating these procedures, you want to err on the side of, no, it's good enough, rather than torpedoing the whole problem because of that 1 point. We're going to proceed under the assumption that it's linear, that there's no pattern in the residual plot. This graph of the residuals is also going to serve as our equal variance check. So what we're saying here is that as I move across x, the deviation of these y's is constant or equal across. And I think on the lower edge here, we're feeling pretty good. It's again that 1 point where, you know, the spread is here, the spread is there, and then all of a sudden you have this kind of wide spread of points in the middle of the graph that tends to come back a little bit as you move a bit farther. It's not the best, but nothing's going to be, you know, perfect. So I think it's, again, fair enough to proceed with saying that, yeah, the equal variance check has been met. And there's so few values that, again, 1 point shouldn't torpedo the entire procedure here. So linear has been checked. Equal variance has been checked. Independence and random is going to come from the equation, or from the stem of the question, I should say. So the only one left is the normal check. And the normal check, we need to make a histogram or normal probability plot of the residuals. So we're going to go back to our plot page, and you can override plot 2, whatever you want, and say I want a histogram. Let's try that one, of the residuals. And again, you can force the residuals in by just going to second list, and mine was 9. So there it is. If I try zoom 9, I get that picture. Again, ignore the line. I actually am going to go real quick and hide that for the moment. Go back to my graph. And there's my histogram of the residuals. Single peaked, overall, not too much skewness, nothing to worry me there. If you don't like that, you can make a normal probability plot. We're going to go back to our plot 2. And that's that last icon there. That's the normal probability plot of the residuals on the x-axis. And zoom 9 there. It's looking pretty good. Overall, pretty linear. Nothing really bothers me about this. So I would say, yeah, either the histogram or normal probability plot, neither of them show departures from normality. The other thing you might be interested in, if you're not wanting to shove the residuals in those commands there, if you go back to stat edit, you can store the residuals, and this is what we did probably in chapter 3, where once you've run the regression, and remember, you have to run the regression to store the residuals. If you try this with your next problem and don't run the residuals, you're going to be using this problem's residuals in the next problem. So we've run it for this one, and I'm just going to call them up and put them in L3. So I can highlight L3 and choose 9, and it puts all the residuals in there. Now that they're in L3, I could go to my stat plot and say I want to graph X versus L3. And now I'm going to get a residual plot that way. The choice is yours how you want to do it, but either of those techniques will work. So just to recap, the 3 things that you'll need to do on the calculator, perhaps if you're not given the pictures in the stem of the question, is residual plot to assess linearity and equal variance, and a normal probability plot or histogram of the residuals to assess the normality. Once you've checked those, and you know, if you're given the graph or not, you have to graph it and assess that all the 5 conditions are met. Remember, the other 2, independent and random, will just be the language of the question. But once all 5 of those are met, you can then continue with the procedure.